they struggle to work against a vacuum or negative pressure, which we have to use for testing the aviation masks at work. So project phases, I'm sure you're all familiar with these. So formulate, so I need to justify the project and plan it. And then we had the implementation, which is to do it, solve all the problems associated with it. And then present and review it, which is what I'm doing at the moment. So all projects have to have a clearly defined goal, and so the goal was an oxygen analyzer with automated calibration. And to achieve this goal, 3 key activities: the hardware design and assembly, software development, the firmware, and then of course it needs to be tested to make sure it works properly. So with the formulation, obviously I had to meet requirements of my work, so I had to sort of justify it to them the cost and the time it's going to take to do it. I had to, of course, make it good for college so that I could achieve my project management tick. And so to do this, obviously, I did a Gantt chart, work breakdown structures. I had to get funding from work. I had to, talk to stakeholders. So that's my work breakdown structure there, listing the objectives I need to do in order to reach my goal. So the implementation, there's sort of 3 parts to it really. Like there's the software. I used MPLAB. I found very early on I needed to structure my code quite well because it's quite difficult coming back to code that's all messy and you can't work out what the hell you've done. And then there's lots of inputs, outputs. I've had to program displays, buttons, the sensor itself, and a user interface basically, so you can actually use the thing. The second part of the implementation was the design, the specifications. So you've got to be careful about the picking the correct components. I've picked a couple of transistors, which probably didn't have the current capability that I wanted. The testing, which I've sort of got here, I did on my Gantt chart have testing right at the end, but I've realised through the project that's pretty much impossible. I had to test as I went, otherwise it would all just gather up and end up being a right mess. So as I went, I sort of improvised a flow meter there to see what signal I've had to send to various valves and things like that. So there was documentation as well. So I normally started off with a sketch, and then I did something on the computer. So I designed PCBs for it, and then built the PCBs, and then finally set up a rig to test it all. And then the final bit was just sort of the final assembly really. So again, documentation, doing some drawings, doing trial fit-ups, arranging everything within the case. There you can see it's just sort of getting everything so it's sort of snugly together and making sure before I drill any holes that it's all going to fit. And then there's the final assembly into the actual case itself. So the results, did it go to plan? Yes and no. I would say there was some trouble with procurement. Some of the valves and sensors were quite difficult to get hold of and had long lead times. Luckily they did just about come in time, but I would have liked them to come earlier so that I could have experimented with them more. Was it a success? Yes, it was a success. It does work. It senses oxygen. It's got an automated calibration routine. It's not quite as user-friendly as I'd like. I'd like to debounce the switches a bit more. And then, so what would I change? Yeah, probably debouncing the switches, improving the calibration, flow control, and the further development would be to get the actual unit into a rig and working with its final purpose. That's going to require a bit more testing. Yeah, if you want any more information about my project or have any interesting things that might help me, or please come and have a chat.